Okay, I'm now recording this.
Great.
Then what I'll do is at the end of it, I'll make it available. If you, as long as you guys don't mind featuring on it.
That'll be nice for me.
Yeah, no problem at all. So I did mean to record it and I forgot. I got so carried away with everybody joining. I completely forgot to click record. Get carried away with these things. Right, so I was going to flip back to the screen again, which was the pilot exam syllabus, which is that one. Right. Did I share it? Share it. Okay, so just, yeah, so basically you have three sections, which is air law and navigation, meteorology, flight theory and instruments. And I'll just, for the purpose of the recording, I'll just repeat what I said before, which is you need to get 70% on, minimally 70% on each section. So my kind of view from an exam point of view on this is that if you know 80% of the data, you've given yourself a 10% margin of failure, if you know what I mean. But it's quite important because you might go through the syllabus. There may be a particular topic in it which you just cannot get your head around. And rather than getting too stuck on that, my advice is get to grips with everything else. And if it's, you know, if there's some small thing you don't understand, it's not a disaster. You know, you can still get through the exam. The one extra bit you should know under air law is that in terms of the collision avoidance rules, there are, I don't know, probably 5 or 6 questions of that throughout the exam. You do have to get each one of those correct. If you fail on one of the collision avoidance questions, you will fail the exam, which kind of makes sense. They're the same questions you get on your CP exam. So just be very clued up. Don't get confused about guys approaching. Do you turn left? Do you turn right? What do you do? Etc. Etc. Just make sure you've got those totally down cold, and you can just rattle them off. You know, sketch them out, draw them out, whatever you need to do. But make sure you know those, because you don't want to fail the exam because you got collision avoidance wrong. And the other thing I will say is, I mean, generally, I mean, I've been running these exams for quite a few years now. I don't know, probably about 7 or 8 years. And I would say a good about 98% of the people, the pilots who take them, pass it. As long as you've done the preparation, you've done the revision, you've been through your pilot handbook, you've looked at the various notes, you've cleared up any odd questions for yourself, you will pass. It's pretty certain.
So I had a question, John, if you don't mind.
Yeah.
Is there any point in actually taking this theory exam without having completed the hours yet?
Right. Well, let me answer that question. You cannot take the theory exam until you've completed the hours.
Right.
You have to have completed all the tasks in the pilot section of your handbook before you can sit the exam.
Okay.
All right.
That rules me out then.
Yeah, just to be very clear about it, you cannot sit the exam and then, so the exam is the final thing you do once you've got all the tasks completed.
Okay.
And as part of, you know, on the actual exam day, whoever's invigilating will go through your pilot task book and will verify that you have done all those tasks. We can't submit it to the BHPA. I mean, I can ask for an exam, you can take it, but it won't go anywhere and it won't get marked.
Okay, fair enough, yeah.
So it's pretty pointless.
It's a good to know thing, the session for me.
Yeah, but it's still, it's good to understand the basics of it and what you need to do, and start, I mean, what used to happen was over winter when we could actually meet, basically from sort of November through to February would be pilot exam time. You know, once a month there would be a lecture covering an aspect of it. We'd get everybody ready, and then come February, shove everybody in a room and get a load of exams and it'll all take them. I don't do that anymore. So instead of that, we've I've recorded various sessions, which hopefully you've found the links for, you've been through. If you search around, you'll find other people have done, you don't just have to look at mine by any means at all.
I think we've got a couple of comments in the chat window. I don't know if you see it.
I don't at the moment, because let me finish on this screen and stop sharing it, and I can bring the chat window up. So final point on this. So first thing is this: if you're thinking of doing the exam and you do not have a copy of the syllabus, get a copy of the syllabus. This is basically your checklist. I'll just pop up the chat question. Greg told me otherwise, as long as tasks are completed within a few months. No, I will. Well, I'm going to disagree with that, unless they've changed something. Here you go. Once you have completed all the flying tasks for the pilot rating, you will need to arrange a time and place to sit the exam with your club's coaching officer. So you definitely need to have passed all your flying tasks. So I'm going to unfortunately disagree with Greg on that point. Yeah, the pilot exam is the final stage in gaining the rating. For that reason, candidates should have completed all of the pilot flying tasks before attempting the pilot examination. They must have completed all the pilot flying tasks before the invigilator returns the exam and the pilot rating application to the BHPA office. As I said, you could sit the exam. We then have to hold on to it until you've got all your tasks done before it can go to the BHPA. Does that clear it up?
That's very clear. Yeah, it says must in really big capital letters. So yeah. Yeah.
As I say, sit the exam if you want, but it won't go anywhere until you've finished all your tasks. So, and if you take too long to finish your tasks, I think there's like we can't keep the exam forever. I think if you've taken it and it's not been submitted within about, I think that's where he was thinking about 3 or 4 months, you'd have to retake it basically. So to be honest, it's simpler. Get your tasks done, arrange to do the exam. We can fit you in, we can sort out exams. That's not an issue. Concentrate on getting your tasks done. But regardless of that, if you're planning on doing it, get hold of the copy of the syllabus. The syllabus is your checklist. Basically when you go through it, it gives you the topics you need to understand. The only topics you'll be asked questions on are the ones on this syllabus. If it's not on the syllabus, you will not be asked a question about it. So you know exactly what you're going to get. My advice is use it as a checklist. As you go through and you get something, just tick it off. Literally, yeah, got that. Yeah. Oh, BMC, no clue what that is. I'll either sort it out now or I'll come back to it. But go through each one, and what you don't understand, you can, if you've watched the lecture, read the notes, and you still don't get it, drop me a message, and I'll either do a talk. I'll either just get hold of you and go over it, or if I think a few people have asked me, I'll cover that exact point. I'll just do some notes, like a short session to cover, the visual flying conditions and meteorological conditions and stuff. So that's something that can be done. All right. So does that kind of clear up the basics of the exam in terms of what it is, what you need to cover? Yeah, I don't want to drag that out too long. All right, let's just stop sharing that for a minute. Cool. So what I want to take a look at then, for those of you who are going to be doing the exam, so I think a number of you are planning on doing it in that first weekend in December. Is that correct? I've seen a few names coming through. Yes, no, okay.
I already have my papers with Steve Ferdy, so I just literally need to go and do it.
Okay, fine.
That's all right, yeah.
Yeah, no, if you can arrange it with somebody else, that's totally fine.
But I still want the advice and guidance.
Yeah.
So yeah, this is really helpful.
Cool. Okay, good. So in terms of the actual exam itself, then for you guys who been studying it, are there any particular areas, bits that you're like, I have no clue what this is about? I like, you want to just sort of get it explained a bit more, go over it in a bit more detail. I've got my PowerPoints here, I can bring them up, I can go over it, I can answer some questions. We can.
I've got a more general question.
Yeah, all right.
Perhaps I could chuck that in. Does passing the exam and getting the pilot rating change any status or privilege under UK air law? I appreciate it makes a difference as far as the BHPA and insurance and so forth, but I don't, unless I'm mistaken, it doesn't change what you're legally allowed to do with a paraglider. Is that right? Or
okay, so it doesn't change what you're legally allowed to with a paraglider. The difference it does make is if you want to go cross country, you can independently go cross country. If you've not done the pilot exam, then basically you kind of need to do cross country under the supervision of a coach. It's a bit of a gray area with the BHPA insurance. Basically, their huge concern is airspace and violations of it. That's their main concern about cross-country flying. And that the pilot exam is their kind of like fallback, if you like, on that fact. It's like, okay, you've done the pilot exam, part of that, you've covered airspace, you've covered the stuff you need to know. So you're kind of insurance, you shouldn't be violating airspace if that happens, or if something goes wrong, it's like, okay, yeah, you're trained, you've done your stuff, you've made that decision, you're capable of doing so. If you haven't done the pilot exam, it's basically considered that you're only insured for cross country if it's done under the supervision of a coach, and the main thing the coach goes over with you is your understanding of airspace. That you really you understand the airspace you're flying through, you've got some means of navigating it, and you'll find that's quite, if you've ever done the BCC challenge, that's mainly club pilots who do it. It's not mainly pilots, and the way they handle it is you have a safety briefing at the beginning, they cover the airspace, what's happening, and that then allows, you're then effectively supervised because you've gone over your flight plan and you can now go cross country.
John, while we're on the topic of airspace, I mean, you asked the question, is there any area that was that would be helpful to know? I think airspace is one of those kind of fuzzy areas for me. I don't know if that's something that you can quickly give us an overview of.
Well, airspace is, when you say fuzzy,
you've got it's various heights and ceilings and that sort of stuff. Is there not?
Okay, that is covered extensively on the flight. That is, I mean, I do cover that on aerial navigation. I'm trying to think the best way of bringing this up. Okay. When you fly, you need to fly with an instrument. Your instrument will have airspace on it. It will tell you, as part of planning it out, you'll take a map. I've got XC Planner on it. Give me 1 second. I'll just bring something up. XC Planning. Okay, I'm just going to share this screen quickly. Very quickly. I share the whole screen. Screen 2. Okay, so you're going to get some sort of tool like this. So let's just turn off spaces. That's right. Space preferences. Sorry. All below. Just right. Okay. So basically, your airspace, you'll have an airspace map, something like you can see on the screen at the moment. And if it's red, you don't fly in it. Sorry, it's a bit basic, but anything, all the stuff in red is restricted. And what you need to know is, as you're flying, is what it's all the various heights. So essentially, we cannot fly in airspace. If you check the syllabus, we fly in category F and G, I think off the top of my head, which is unregulated airspace. We cannot fly in things, in basically these.
So is that all the red tinted areas that we shouldn't be flying in? Is that a simple way of putting it?
These all have heights. These all have up to certain heights or above certain heights. I'm not going to get into all that because it is covered on various lectures. But basically, for example, this bit here, sort of between this section is here, format in the middle of the screen. This is all 4,500 foot. This is a 4,500 foot airspace gap. If you're under 4,500 feet, you can fly through it. It's from 4,500 feet. In that section, you can go. So that's something you can go under. We fly like above us all around here. It's 5,500 foot airspace. As long as you're under 5,500 feet, you can fly in it. If you go above 5,500 feet, you can't fly in it.
Right.
So
even though it's free and not tinted, there's still restrictions on how high you can fly even in that space.
Yeah, absolutely. Just if you grab an air map, and that's why part of what you need to do is take an air map, take a look at it. Get an air chart, take a look at the air chart, or just get like one of these XC route things, and take a look. And as soon as you turn on the 5,500 foot airspace, that's it. It's not. Most of the UK is covered. There's a few spots that aren't, but certainly for where we fly, it's definitely covered. And it drops very rapidly. This is this line you see here, which runs from sort of Falmer in this V shape. This is the 4,500. Sorry, this is the 4,500 foot line. As you move into this line, you can see running across the screen. That's dropped to 3,500, and in some places it then drops to 2,500. So it may even be 2,500, but it drops quite rapidly because you're in Gatwick airspace. So this is all very restricted airspace, basically.
John, can I just ask on that? I realise it's slightly off piece, but that looks like a very useful tool that you've got there for looking at airspace. Are there any particular tools that you recommend? I've got the old printed chart on the wall behind, but something that is very useful.
Yeah, I mean, this is an XE planner. So this is, as it says, this is flyxe.app, which is very useful. And it gives, it's something you can put up, you can visually see the airspace. It's designed for planning flight plans, which is a separate talk entirely. So I'll just come off that one briefly. Anyway, does that answer your question on airspace, Abby? Without getting into too much depth on it.
Yeah, no. I think you've given a quick overview. I think that's helpful. Yeah. Cool.
All right. So any other particular topic? So let me refresh you. I'm going to bring the syllabus back up. It's more if there's certain things that you struggled with, like you looked at, okay, I have no clue how to cover this aspect of it. I'm just gonna bring the syllabus up. I just want to go over a couple of things very quickly on this, which one of them is pilot exam syllabus, share again. Right. On these sections, so first section, which is this, air law and navigation. Air law and navigation is very much, unfortunately, one of those sections where you just have to go over it, study it, memorize it. It is what it says, it's law, air law. And, you know, things like know the dimensions of air traffic zones and military air traffic. You just have to know them. There's no shortcut to it. So you just go through it, you sketch them out, you get them memorized. You know the rules. Well, the rules are there, you need to know damn cold. All these little things, be able to define VMC, VFR, like the visual flight rules. Again, they are covered in the various notes. You just have to take them, memorize them. There's nothing fancy about this. It's one of those boring old school routines of, yes, I've studied it 10 times. I've repeated it 20. I kind of have it now. Great. I'll now move on to the next section. And you just need to do that for that section. There's no shortcut to it. By all means, you know, watch the video, go through the notes, read the section in your book. So that's an area you just kind of need to get to grips with. Met and flight theory are quite different. So meteorology is a lot more practical. You know, for that, you can use it. You can take a look at charts. You can look out the window. You can look at the sky. You can check the weather. You can see, okay, I've looked at a pressure map. Does it make sense? Did the weather relate to what I saw? So this is a lot more, you know, for a lot of this, it's quite, there are various practical things on it you can do. The one bit on this that sometimes catches people out is basically this section here. So fully understand convection, the birth and development of a thermal through to plotting the progress of a thermal given the ELR, environmental lapse rate, and initial temperature. That represents a reasonable chunk of marks on your exam. And you kind of need to be familiar with that basic structure of creating a diagram, understanding the basics of that. And that's that is a fairly crucial bit. And if that's something that you're not totally 100% with, that's probably worth covering now briefly to go over it, just to make sure you understand lapse rates, the relationship between, you know, cloud-based, cloud tops, how you work them out. You need to have that sorted out in your head and diagram it out and do some examples so that when you come to see the exam, you don't get flustered by it. Because you will lose a chunk of marks on that if you don't have that down cold. All right. Anybody are you all happy with that, or is that something you? Yeah,
I mean, if you can, you know, give us a bit of an overview of that area, that'll be helpful.
I think it's one of those ones which I've done completely separate talks on when I used to do talks. Okay, we're going to cover lapse rates this week just because it's like. Yeah.
Okay. Is it that complicated then?
It's not actually that complicated. It's just that people get confused between saturated, dry, environmental. The abbreviations throw people, and they. So let me just clear up a few basics on it first, without getting into too much technical stuff. Okay. So lapse rates are simply the rate at which things occur, and you'll find this word thrown in, which is adiabatic, dry adiabatic lapse rate, saturated adiabatic lapse rate. So adiabatic is just to do with an enclosed system, basically. And if you just look at the basic mechanisms of what a thermal is, what clouds are, and what's happening, you'll understand what these are. So the way, you know, so what is a thermal? Basically, at ground level, the sun heats the ground and it heats the air to a point where it's warmer than the surrounding air and it will release. So, you know, it's like, why does air rise? It rises because it's warmer than the air around it. That's the basic principle. As long as it's warmer than the surrounding air, it will keep rising. As soon as its temperature drops to the same as the surrounding air, it will cease to rise. So when this pocket of air rises, it's considered dry. Now, dry is quote unquote dry. It obviously has moisture in it, but the moisture hasn't condensed into droplets. So it's given a technical name. This is a technical name of dry. So as this pocket of air rises, it has a dry lapse rate, a DALR, dry adiabatic lapse rate. That's how much this pocket of air is going to cool as it rises, like 2 degrees, well, top of my head, I can't remember it is now, but so many degrees per 1,000 feet. As it rises, it starts to cool. It will cool to the point where its temperature matches dew point. So when its temperature matches dew point, what happens to the particles inside this pocket of air?
Does it become rain?
They become rain. They condense, so they become droplets. They may or may not be rain, but they will condense into droplets, which then become visible, which is cloud. So at that point, it goes from being dry to saturated. It's like there's no sort of between. It's either dry or it's saturated. So it rises as dry, it gets to dew point. Now the droplets can form as droplets. So it's now considered to be saturated. And as a saturated layer, it will now rise, it will cool at a different rate. So let me see if I can quickly find a diagram to explain this. To give you something on it. Give me 2 seconds here. I think I've got to share somewhere. Like that. My net stuff. Drag this onto the screen. Pop it open. And fronts. Oh, it's okay. All right. So I've actually got, if you check what I'll do, I'll drop the, are you all on the coaching group, Telegram?
Yeah, I am.
Yeah, okay. For those who don't have it, what I'll do, because I've got PowerPoints for each of the videos, I will drop the PowerPoint, the Met, the air law, and the other one, flight theory PowerPoints onto the Telegram group, so you can all download them. That I think you'll probably find useful, because then you can just go through each slide, take the bits you want, take a look at it. Can you all open PowerPoints?
Yeah.
If you struggle, let me know. I can dump it to a PDF. It's a bit more cumbersome than the PDF. I can convert it to PDF if you need to.
I mean, just an idea, John, is that something that could be put on the website, on the coaching bit?
Yeah, I'll try and get them dumped on there. I used to have problems before because there was a limit on how the file size it would take, and these are all bigger than the limit, so annoyingly. But yeah, no, I'll see if I can get them on the website, because then they're there, you've all got access to them. But otherwise, I will dump them. They should upload to Telegram. Will take them. So I'll dump for now. I'll dump on Telegram.
Telegram is convenient. I mean, all of us are on Telegram group. That's why we're here, I guess. But yeah.
Yeah, I mean, I find Telegram is good. It's there. I dump on, then you can download them and get away with it. Right. So I'm going to bring up my PowerPoint and share that. Okay. So you can all see the PowerPoint now.
Yeah.
Great. So this is in the notes. So you'll get these are in the PowerPoint. Basically, what I've done a step-by-step example showing it's obviously not. These are just artificial values, but it'll give you an idea of how each thing works, and this is kind of what you might get in an exam. Not saying you will, but you might. So the kind of data you'll get initially will be this little chart on the left here, temperature and height. So this is your environmental lapse rate. This is like a measurement of what's happening in the environment and how the air is actually cooling as you get higher. That's all it's showing. So in other words, that so the temperature on the ground is 24 degrees at 1,000 feet, at 17 degrees, at 2,000 feet, it's 15 degrees, and so on. And you simply plot that on your graph. So here we are at ground level 0, we have 24 degrees. At 1,000 feet, we have 17, etc., etc. And you draw your line. And then we've got a piece of data at the bottom here, which is that dew point on the day is 14 degrees centigrade. There is a lapse rate of 0.5 degrees C per 1,000 feet. That's the dew point. The dry adiabatic is 3 degrees centigrade per 1,000. Saturated is 1.5. Those are set figures. Like dry adiabatic is 3 degrees centigrade per 1,000. So that doesn't change from day to day.
So John, I had a question though.
Yeah.
So what's the difference between the lapse rate that is shown here, which is 0.5 degrees per 1,000 feet, and
dew point?
The ELR? Sorry,
that's to do with dew point. It's a dew point lapse rate.
And what's the dew point lapse rate then?
It's how dew point. It's how the temperature of the dew point changes with height.
Okay.
Basically. Environmental lapse rate changes. It's the environmental lapse rate. It is the, if you went through the layers of air right now, it would be the temperatures at those layers. That can be as varied as anything. There is no set. I think that it is the environmental lapse rate. It's like it is an actual measurement of what's happening at the different layers in the atmosphere. Okay.
Yeah.
Whereas the dry adiabatic and the saturated adiabatic are fixed. They are always 3.0 and 1.5. Those are the accepted figures for them. It's what happens to a parcel of air. So this blue line you see going up here, highlight it. That's my dew point line. So that blue line represents the dew point. With that's where this 0.5 comes in, and the dotted line is showing my dry. That's my 3 degrees per centigrade line. That's my dry adiabatic. So that red dotted line is how a parcel of air rising from the ground will cool at different temperatures. So it starts here at 24. Here it's gone to 21. Here it's gone to, I don't know, 17 or something. I don't know, roughly, whatever it is. So that's just how it's rising and cooling. That's your thermal going up.
So does dew point always start at ground level? So when it says 14 degrees, is that at ground level?
Yeah, you'll get it's a. I mean, obviously you can start where it's light, but as a basis, you take it at ground level. So now you see the red line goes. You've got the dry adiabatic here until it meets the blue line. So here your parcel of air has risen. It's cooling. It now reaches dew point, so it saturates. Okay, so now after the blue line here, it's now cooling at a rate of 1.5 degrees per 1,000 feet. Do you all see that?
Yeah.
Yep, cool. So rises at this rate, saturates, now it rises at this rate. So where this blue line and red line first meet is cloud base. this red line now rises until it hits this little inversion here. So it can't rise anymore because the surrounding air, at this point, it ceases to be cooler than the surrounding air. Sorry, it ceases to be warmer than the surrounding air. So it will stop rising. So that point there, where the dotted line meets this inversion, is the top of the cloud. That's your cloud height. And that basically, now getting into more complex, that's basically it. That's what you need to know. Environmental, the dry line, so it's the dry right keeps going till it meets the dew point. Once it meets the dew point, it's saturated. Saturated will rise until it meets an inversion, and then it will stop and you get a cloud top. So just a sort of little bit of Met. If that inversion wasn't there, and let's say that the red line kept going, mess up with it. If you imagine that inversion wasn't there, that dotted line would never meet it. So they would just keep going up. That's when you get very unstable days and you get thunderstorms. It never, the air is always warmer than the surrounding air. The pocket of air rising is continuously warmer and warmer. So it just keeps going up and up and up. And that's where that will generate thunderstorms, or big thunderclouds. Okay. So it's the
sorry.
Yeah.
Can you just remind me, the dew point lapse rate of 0.5 degrees centigrade per 1,000 feet, is that a fixed number, or is that depends on the day number?
Again, that's accepted as a fixed. That's just what it is, basically.
That's lovely.
Yeah. Yeah. So basically, those are your basics. That's lapse rates. And once you've got it in your head, it's like, okay, parcel of air, until it gets to dew point, it's dry. Once it gets to dew point, it's saturated. And the rate it cools changes when it switches from dry to saturated.
So is it a good idea to actually memorize those numbers then? 0.5 degrees centigrade per 1,000 feet for dew point, 3 for DLR, and 1.5 for SLR?
It's no real harm. I mean, you can do. You will be given those in the exam. You won't be asked to memorize those. So I wouldn't worry too much about that. It's more, okay, so this is where we switch from, there are two aspects. One aspect of this is, what do you need to know to pass an exam? The other aspect is, as pilots, this data is actually really useful to understand for your flying. It will give you a real understanding of what's happening in the air, thermal activity, and various other things. So, and this is where I kind of switch out of exam mode, and certainly for the Met, my advice is study it from the viewpoint of improving your flying. You know, air law is air law. It's just air law. You just know the stuff. But when you get into Met and theory of flight, I find it's much more useful for your students to actually think, okay, great, that's a useful piece of information. How does that apply to my flying? How can I use that to help with my weather forecast? How can I use that when I want to go cross country to look for better days? And one thing I will just point out on this diagram, you see the solid red line and the dotted line, and you see it's not, the space changes as you go up it, it's not a constant fixed distance. Basically, the bigger the separation between the dotted line and the red line is kind of how much strength there is in that thermic activity. So the bigger the gap, the stronger the thermic activity. So here, for example, in this example, I'm not saying this is typical, this is what this shows. You've got, you know, quite close to the ground, it's weak. And then as you get up a bit higher, some sort of, you know, like 1,000 feet up to about 2.5, it actually gets stronger. And then it tapers off a bit as you get towards the cloud. And you may even, you know, and it's kind of useful to know that. Now, realistically, that rarely happens. Generally what happens is you'll find most thermic activity runs very close to the environmental lapse rate. So it's like tediously slow, and it just widens a bit as you get near a cloud base, and you'll notice that you get this little acceleration as you get to the top. But that's I won't. Yeah, we'll leave it at that. I'm not going to get something else to do with that.
I don't know if this is related, but people generally speak of cloud suck at cloud base. Is that any connection with this, or
well,
that's an entirely different thing?
No. It's literally to do with this. If this was, if this was a slightly different shape, if this was, say, narrow, and opened up as you got closer to the cloud, then yeah, you'd find more pull as you got closer to the cloud. I think a little bit is, I think a part of the cloud suck is some of it is like psychological, and as much as, if you're 1,000 feet below a cloud, it seems quite far away and it seems to like take a long time to get to it. When you get to about 50 feet below a cloud, it looks like it's approaching really fast because it's this huge thing above your head. So you do get this slight apparency of being pulled into the cloud. Truth of the matter is you're just going up in the thermal. And you haven't given yourself enough angle of escape to get away from it. That's nothing to do with, you're not going to be asked about cloud sucking in the exam, but part of it, I think that is just a mental approach. People, it's just your view of it when you're flying.
Okay. So perception then.
It's a perception. If you're 1,000 feet below the cloud, it's like, oh yeah, I'm nowhere near it. And then you get to 500 feet, then you get to a few hundred feet, then you get to like 100 feet below, you're like, oh crap, I'm now, you're kind of aware of the fact you're too close to the damn thing. So now it's, it feels like you're being pulled into it faster. But truth of the matter is you will probably find as you go up in the thermal, there are points where it will increase in strength. That definitely happens. And that's just to do with lapse rates and air temperature and stuff, so if the air temperature suddenly drops, so the air now rises faster through that section, yes, you'll increase it, you will go up faster, basically. Anyway, but that, let's say it's worth, once you've got the notes, my advice is, take these figures, start from scratch, draw it out for yourself. So you just got it down as okay, draw these lines on, that's my dew point, that's my dry lapse rate, that's my saturated lapse rate. I've got one showing. Let's see if I've got one that shows. Okay, so this is just like basic data. Any thermal will continue to rise until its temperature is equal to that of the surrounding air. And that's just basic physics. It's like the air is rising because it's warmer. And so then you see, your cloud will build until the saturated adiabatic meets the environmental line. So basically, once it's saturated, it will continue to rise until its temperature meets that of the environment. And then it cannot rise anymore. That's it. It's now hit the point where the temperature's balanced out, so it stops rising. And that's the top of your cloud. Then it says without an inversion, thermal would rise up to the next layer, the tropopause, and it becomes a cumulus, a CB. Anyway, I don't want to labour this point too much, notes are there, but does that kind of clear up for most guys and as a key area?
Yeah, definitely.
It's just one of those points that I know people get unstuck on. The other thing you need to know is cold on Met, is fronts. Again, I'm not going to go over notes there, but make sure that you know what a cold front is, all these characteristics of it.
So on that front aspect, when we go to any of our sites, we always speak about sea breeze front. So
okay, let's not get confused. That's something very different. Let's just look at it.
Okay.
Yeah, totally different. When we talk about fronts, we're talking very specific about cold fronts, warm fronts, occluded. You need to understand what a cold front is. You need to understand what a warm front is. They are very specific. They are very exact definitions. And you'll see in the notes, they have very specific characteristics. You need to be able to recognize those characteristics, like cold. You will find there are questions where they'll say, which of these is a cold front? And there'll be things which look similar in them. And if you don't know exactly what it is, you will get it wrong. This is where people kind of mess up on the Met a little bit, is they don't have this quite down. Again, so you need to know warm fronts, high cirrus, stratus, lowering cloud base, rain, move slowly. I mean, I've put these little cue cards in there so you can just go through and go, oh, that's a warm front, that's a cold front. But it's, again, you kind of need to understand, fronts are key to understand. Any of you thinking of doing the exam, I'm just going to flip out this very quickly. I'm going to stop showing that now because I've covered that. The one part I will go over, that, can't save. Met, you need to be looking at, okay, to bring it up, so bring the Met up. Get it on screen for you. Okay, share that. All right. Make sure each day when you look at the weather, you look at these synoptic charts. Because this, and you understand, okay, the blue is the front, the red is, sorry, blue is the cold front, red is the warm front, and these pink things these are occluded fronts. But get used to taking a look at them and looking at, okay, what does that mean? What's happening with the weather? What's going on here? We've got these fronts coming through and these pressure lines. What's going to happen about? Is it wet? Is it windy? What can I determine from that? And again, you will get questions on the exam where you're given a synoptic chart which has fronts and things on it, and you will be asked to say what is happening with the weather at those points. So make sure you understand which ones bring rain, what happens when you get cold fronts meeting warm fronts, all your stuff about, make sure you remember with low pressure systems, high pressure systems, which way the wind goes and everything, all that sort of basic stuff. Make sure you've got that. But again, use it. My advice is take a look at a pressure map and look at it and think, okay, well, what should the weather be like? And then have a look at the forecast and see if your concept of what it should be based on that actually works. And then flip between the two. Take a look at that, take a look at the forecast, and just see, well, okay, well, why are they saying that when I'm looking at this? Does that make sense? I don't know. But it's very useful stuff. So before we had all the various weather apps and stuff, in the early days prior, that's what we used basically. We looked at a synoptic chart and we worked out what was going on. There were no clever apps and things like, what? Oh, it's chart, okay, pressure lines, blah, 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 oh, that much pressure, the wind's going, blah, blah, blah. And you get used to that. So it's easy to just get used to apps telling you everything. And it's much better to look at something like that and get, because you kind of want an overview, especially with the UK. We're affected by so many different air systems. You kind of want to know what those are, how we're affected by them, what kind of conditions they bring, that sort of stuff. Okay, so if you're not doing that between now and exam, just do it. Each day, spend a few minutes, look at the synoptic chart, get familiar with the symbols. It's like, yes, that's a cold front, that's a warm front, that's an occluded front. There's my high pressure system, there's my low pressure system. Okay, high pressure, winds going clockwise around it, low pressure, anti-clockwise. All that sort of stuff.
I don't know if you've got enough time. I was just wondering if it were possible for you to look at one synoptic chart and just kind of draw out what the weather is expected to be based on that.
No, I think you should do that.
If there's no time, yeah.
No, that's why. That's one of those practical things that it's easy to do. You can do it. You just look at the map. and you know it's, you've got the answer because you go, let me look, and you know, it's easy to cheat. You just, not cheat, but you just flip back to the actual forecast, and you go, right, well, what is the forecast? Okay, well, it's actually, that's my forecast. So, you know, just look at it. Like for tomorrow, you can see you're expecting, you know, northwesterlies, west northwesterlies, sunny, not too bad. Got flying tomorrow. And if you take a look at the synoptic, just flip between them and go, okay, what's the synoptic for tomorrow, lunchtime? What do we see? Okay, so you've got high pressure system here pushing in clockwise. Yeah, you can see what's generating those northwesterly winds.
Right. Okay.
Because
I've looked at this and I've always wondered. I mean, it's just 3 lines covering the whole UK. So,
well, look at a bigger map.
right. Okay.
Look at one that shows you a bigger. This show. Don't you look at this much of the UK? You see 3 lines on it. It's going to tell you nothing. Well, that's not true. You know, look on the bigger one. If you're looking at the Met, I think the Met Office app on notepads, iPads, and phones only show you a small picture. They show you a little bit, and then they show a few lines. Look at it on the web, and you'll see the whole chart for that whole section of the planet, and you can see where the lows are forming, where the highs are. It makes it a lot more useful. You know, you can track through from sort of day to day. You can see the progression just by doing that. You can see, okay, you can see how the high pressure systems are moving. It just gives you a better idea of what's going on. But yeah, you look at that for tomorrow, you can see, great, it's a high pressure system pushing in from the sort of southwest. That's going to be driving it. So we would expect to see sunnier conditions, northwesterly winds. Depending on exactly where that center of high pressure is, will affect the wind strength and direction. That's why it's looking brighter tomorrow. There's a high pressure coming through. So that's just a matter of, you just do that. That's something you do. You know, it's not, yes, it helps with exams, but it helps with your flying. So it's one of those, just do it type things. But having said that, if you take a look at my notes, you'll see I have taken some examples of synoptics and walk you through.
Okay.
They are on there.
That's good.
Yeah. All right. I think, let me just bring up my, sorry, I'm just going to quickly put the syllabus back up for me. So MET, those are, okay, yeah. So those 2 things on MET, the synoptic chart and the lapse rates, well, synoptic chart, lapse rates, fronts, those are your key things. And you do need to have them, you know, sort of programmed in so you can deal with them. Cool. Leave that there. Flight theory. I'm just going to take a quick look at that. Again, there's a bit on that that sometimes throws people. I'm just going to go over that area briefly. And I think that's kind of then we'll look at if there's any other bit. I'll just go as quickly with you. Syllabus, share it again. Okay, so flight theory and instruments. So you've got a couple of bits here. So describe the relationship between induced parasitic and total drag. Understand and be able to use a polar curve. So this first bit, relationship between induced parasitic and total drag. I think in the pilot handbook itself, there's a very nice diagram of that, if I remember rightly, which actually explains it very well. Explain that, certainly in the notes. I think I've nicked the diagram out of the pilot handbook, to be honest, and just put it on there. But make sure you've got that. You know the difference between induced and parasitic. Again, I'll put the diagram soon. But the key thing, polar curves. So I just want to quickly go through this because this, again, it's one of these things which is kind of it's kind of useful to know. I mean, I don't know anybody when they're flying and go, I wonder what the polar curve for my wing is so I can work out my flight path. But the principles of it are relevant to flying. And again, it's one of the ones you will get a question on polar curves, you will get a diagram, you will get asked questions about it, and you need to be able to answer them. Otherwise, you're going to lose a chunk of marks on it.
Is there somewhere where we can actually find out what the polar curves for our wings are? Because I've looked and looked and can't find.
No, I don't, to be honest. I think there's something like they used to be published, but it's more of a sort of theoretical thing. It's a principle of how they work. Getting an exact polar curve for your wing. Stick a question. Some I don't know the answer to that question. Stick something on the coaching group. Someone might go, oh yes, here you go. Here's a link for the the EN.
I think your vendor may be able to provide that.
Say what? Sorry.
The wing vendor, the paraglider vendor.
I doubt it. It's not. You'll find it's the overall principle is something that will assist you in your flying. Knowing the exact aspects of it, you can kind of, once you understand the principles, you can kind of play around with it in the air to get an idea of how it works on your wing. So let me just quickly stop sharing that for a second. And I'm just going to bring up, close that one. I need flight theory instruments. Well, I'll just quickly skip through this and find the slide. Drag. Curves. Here we go. Okay. Right. I'm just going to share this quickly. Go to this point. Explain polar curves. Sharing. Share. Okay. So flight theory instruments, speed to fly, polar curves. So polar curve is very simply a graph of your airspeed and sink rate. And it will vary. It'll be similar from wing to wing, with slightly. In other words, no wing's going to be vastly different to this. The curves will flatten or tighten slightly, but the principle will be the same, which is obviously it starts at a speed, because below whatever your stall speed is, you're not flying. So it won't. It starts here because you need some speed to be in the air in the first place. You'll then look at what these diagrams are. As you speed up, you'll get to your sink rate will change a little bit. As you get faster and faster, you start to increase your sink rate again, which you probably know. If you put on bar and you're really hammering it, your sink rate increases. So hence you get this curve. Basically, I mean, you could probably work it out for your wing by going out and taking measurements of how fast am I going, what's my sink rate, and work it out. But it will be essentially that pattern. So let's graph it. Now, min sink speed. This is the speed to fly at, which will give you the minimum amount of sink. And basically, it's clearly the highest point on the graph, because anything below that, you're sinking faster. It's just, so you find, okay, what's the highest point? What's that speed? Okay, at that speed, I am flying at my minimum sink. So it's quite simply, the top of the graph is clearly your minimum sink. It can't be anything else. Now, that is not necessarily your speed, your best speed to fly at. We go to the next one. So to get your best glide speed, which gives you the most efficient gliding is you basically take a line from the origin, and I mean, obviously for those who are inclined the technical, it's the tangent. It's basically where that line touches the curve. So at that point, that gives you your best glide speed. So you can see it's faster than min sync. It's faster than just, this is why you'll see you generally advised to fly without, your instructor will say, hands up. Well, they'll say, fly faster, or it's, don't have as much brake on. So I know Inga's heard that from Steve lots of times. Get your hands up! Fly faster! Because you actually fly more efficiently when you're flying a bit faster. As you can see, your best glide speed is not here at min sync. It's here, syncs a bit more, but you're actually going to get further. And there's various ways of looking at that. But for the point of view of this on the graph, so your best glide is that line. Now, oops. So this is one of these things which people sometimes slightly have difficulty getting an understanding of. But if you add weight, in other words, if you add ballast, if you're flying with more weight, so if you add weight, you basically increase speed. But this is a curious thing. The actual polar curve remains the same, and obscurely, the lift to drag ratio stays the same. So you're actually flying on the same angle, but faster. So you'll get to where, it does mean you'll get to the ground quicker because you're going there faster, but not because it doesn't actually result in more, like the lift to drag ratio remains the same, obscurely. So it's one of those points. It's like, increasing weight doesn't change the lift to drag ratio. Worth knowing. And then.
So does that mean that we get the same glide distance with more weight?
You don't get the same glide distance. You get the same glide. You're going faster. And you'll find it's you get the same glide distance. Ooh, it's a tricky one.
Faster, and you're sinking faster than.
I mean, put it this way: you're not. Yeah. Unless you're planning on flying with a load of ballast, it's not that relevant.
The ratio remains the same. So the angle you're going down at must be the same. So from the top of the hill, you get the same distance, wouldn't you?
You go the same distance.
You get there sooner.
You get there sooner. You get there sooner, basically. So you have less time to, But I say so. You'll often see it's why competition pilots will often fly with extra ballast. So they've got the speed, but they're on the same glide. We're not competition pilots. Well, might be, I don't know. But you're not going to get deliberately shove bricks in the bottom of your harness so you can get some extra speed as you fly. Well, I hope you do anyway. But if you speak to a comp pilot, they often will carry quite a lot of ballast to increase, to get that extra glide ratio. It's not unusual. And you'll see they have big harnesses, they're heavy kit. And it's designed that way so they can get more speed out of what they're doing. But anyway, it's just a simple datum that the angle stays the same, you're just going faster. So it doesn't actually increase. I suppose it gives the appearance of increasing sync because you do get to the ground quicker. But as you pointed out, you're arriving at the same spot, you just get there sooner. Now, in terms of getting your best speed to fly, you basically, what you'll be taught, so you've got the basic diagram and it'll be, okay, so now you're in a headwind or you're in sinking air. And quite simply, you kind of do the opposite of what's happening. So if the air's rising, then you would displace the origin, your start point let's take, this is sinking air, so let's do sinking air. If the air is rising with space origin below, down by the mountain, so it's sinking. So to get your best glide speed, so here we've got like a headwind of sort of well, let's call it 10. It's just off 10. It's in a headwind of 9. So basically, we would say, right. So rather than starting our line from 0, we're going to move it across to this point and then see where it meets the graph. And we've got some sinking air, so we're actually going to go up a bit to allow for that. So again, it means the point your speed will obviously, because where it touches the graph is now further along, you need to fly faster to maintain the best glide angle. Which kind of makes sense logically. You know, if you're flying into wind in sinking air, you go faster. If you were kind of downwind in lifty air, then you would be moving, your point of origin would go to the left and down a bit. So you'd actually fly slower for about a sink rate. Sorry, for the correct speed to fly. So essentially, if so quite simply, you know, if the headwind was 20, you would, instead of starting here at 0, you would put your line here at 20, and then draw it down, see where it met the graph, and that would give you your speed to fly. Okay. So it's just how you adjust that to make that work. So basically, you're just playing around with it to move your start point basically the opposite direction of what's happening. So if you've got a headwind, move it further along, which it makes intuitively makes sense. In a headwind, you need to be flying faster to get where you want to get to. Is that basically okay? Yep, cool. All right, as I say, you'll get the PowerPoint, you can go through it. Those, I think, are kind of the key bits that, if you're not familiar with it, the diagram, people get thrown. They'll suddenly see a diagram, it's like, oh, crap, you know, it'll be, where is this, where is that? Mark these points on it. And if you don't just have it sitting there, you will struggle with it. And, you know, again, I can't remember, there's a chunk of points just on that one thing alone. So make sure you're familiar with it, make sure you're happy with min-sync and speed to fly and things like that. But again, this is something you can then use. You're not going to know your polar curve, but you can use that principle. You know, if you're flying, you're in a headwind, you want to get to where you're going, maybe, you know, you might need to put some bar on to actually get a better glide. I mean, if you think of it in the extreme case where if the wind matched your trim speed, hands up, where would you be going? Yeah, no, you'd be gale hanging. So you're never gonna, if you wanted to get somewhere, you're never going to get there. So you might go, oh yeah, I'm on min-sync, it's brilliant. Yeah, I'm just staying at this height, but you're not going anywhere. So you now increase your airspeed with a bit of bar. So now, yes, you might be going down, but you're progressing, you're going forward, whereas you weren't going forward before. So, you know, given that you've got some destination in mind, then in that, you can see in a headwind, you need extra speed. It kind of makes sense. In sinking air, you know, that's where you'll get this, your people say, look, when you're going through sinking air, fly faster, get through it quickly. Don't mess about in sinking air, get through it as fast as you can, and now try and get your height again. Just because of this, it's like, yeah, sinking air, get through it fast. You want to be in it. You want to be in it for as short a time as possible, essentially. Cool. All right. Are there, stop sharing that for a second. Stop sharing. See there's some comments floating around here somewhere. So I've got, can you find, okay, everyone, thank you. Someone's posted something on the message about, can you find an answer? Polar PDF, all right. Add a new app where you can upload your X logs, polars and other curves. Okay, cool. All right, so yeah, so in answer to polar curves, if you look at the notes, apparently the current sky winds has answered that question for you. Very good. Okay, very good. All right. So for the guys who are planning on sort of taking the exam in the near future, is there anything you want to go over? Any specific points that you would like answered? No, fair enough. You don't have to have questions. I'm quite happy if you don't have questions. Make my life a lot easier, to be honest. All right. I mean, you know, for those of you who are looking at it, it's I'd say treat the exam as pilot development. Don't treat it as just a mental exercise for, oh, I'm going to get a piece of paper. You know, take the data, use it to improve your flying. You know, the more you understand that, the weather, your wing, how it flies, will make you a better pilot. It will give you a better understanding of what's happening on the day. You know, truth of the matter, once you start flying cross country, you're going to be flying into changing air conditions all the time. You know, as you fly further and further, air changes, air masses change, conditions change, and understanding the weather and being able to look at it and read it will make your cross countries better and safer. There's no doubt about that. You know, when you're just flying locally, you're only looking at what's happening in that one area. It's not, I'm not saying it's not important, you know, especially on our sites. You still need to understand the weather. The weather changes all the time. You know, the fact the wind's blowing at 10 miles an hour when you arrive on the hill and take off doesn't mean it'll be blowing at 10 miles an hour 20 minutes from then, or half an hour or an hour from then. You know, wind changes. It can go from nothing to blown out, from blown out to nothing. So you need to appreciate that and keep an eye on it. And looking at forecasts, synoptic charts, getting an idea of what's happening with the weather for that day will help you predict it. I will just briefly go back to a question I think Abby asked about fronts. I said sea breeze front.
That's right, yeah.
Okay, so for sea breeze fronts are very, very relevant for our sites because most of them are within 10 kilometers of the sea. So we get affected by it. Now, sea breeze fronts are something in the Met section. You do need to understand what they are. And so I'll just very briefly explain it, just so you understand it. So first of all, the key thing that determines any wind is what?
Pressure difference.
Yeah, exactly. So basically, if you look at why does wind occur, it's because air is flowing from between pressure systems. You know, it's going from high pressure to low pressure. It's just physics. High pressure here, low pressure here. It has to balance so the wind goes between the systems. So, what is a sea breeze? How does it work? Sea breezes occur where the land mass is heating up. So because the land is heating, the air is rising. What pressure does that create in that area with the rising air?
Low pressure. Yes.
So basically land heat, sun heats it, air rises, you have low pressure. This air goes up, it's got to go somewhere. It will go, because we're close to the sea, it goes up, some of it will push out and it drops over the sea. As it's dropping over the sea, it's cooling, it's descending, so you get a high pressure system building over the sea. So now you've got high pressure over the sea, low pressure on land, so you now have a pressure difference. So what does that do to the air between them?
Causes a wind, a breeze.
Yeah, so this is your sea breeze. It's driving so the sun is driving this sea breeze. It's causing the pressure difference of high pressure over the water, low pressure inland, resulting in air being pulled inland. And it can get very strong. So bear in mind, this is not a Met wind. It's not like there is a southwest wind. You know, we're talking about the Met wind if you're at the dike, it's north, northwest. It's summer, it's coming through. The sun's out, it's building, 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 and it will now start this. So this air is starting to build, 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 and push towards the met wind of the northwest. So now you've got the dynamic wind, the meteorological wind, going north, northwest. You've got this sea breeze wind going south, southwest, whatever the direction happens to be, and you've got two air masses that are going to meet. So when air masses meet, you get a front. So this is the sea breeze front. It's the sea breeze meeting the dynamic, the meteorological wind, and they're two air masses. So you'll actually see this. You can see a cloud layer as these sort of like trailing fingers coming down for it, building along the coast and moving in towards the site. And that's basically a sea breeze front. It's two air masses meeting. Generally, the air coming from the sea is cooler, slightly more dense. So it tends to push under the. So you've got the cool air coming in. You've got the warmer inland air, which gets driven over the top. And so what you can get is this kind of convergence line where you've now got the air, as long as you're on the right side of it, the dynamic air is being driven over the top of the sea breeze. And so you get this lifty line of air that can occur as the sea breeze comes in. The problem is, so it can be very good, it can also be insanely dangerous, because if you get it wrong and you end up in the sea breeze side of it, you're in really rough, crappy, turbulent air. So it's a fine line to play with. But you kind of need to understand it, especially in summer on our sites, because quite often our flying days end about 1 o'clock, 2 o'clock each day, because the sea breeze comes in, that's it, you can't fly anymore. It's knocked unless you're away. But anyway, that's the front. That's the sea breeze front, basically. Okay, it's in the notes.
Yeah, that's quite good to know.
Yeah,
because I hear the word bandied around without really having an understanding of what.
Yeah, I suspect several people bandy it around without understanding what they're saying either. The key thing, this always come back to basics. It's like, why does wind occur? Wind, it occurs because there's differences in pressure. Why are there differences in pressure? Because some air is going up and some air is going down. Where it's going up, you've got low pressure. Where it's going down, you've got high pressure. The wind will go from high pressure to low pressure. And once you got those basics, most of the Met falls into place. It's like the sun drives it, heats it, rising air, low pressure, sinking air, high pressure. Okay, now I've got a system. And now it starts to you can sort of start to see how it all works.
The problem is the sky never looks like the theory, does it? And look at the clouds and go, what's going on there?
Well, weirdly, you might say that. I won't go into it now, but once you start looking at like tapigrams and the full thing, they're surprisingly accurate. If you look at the couple of talks I've done on RASP and how that works, and it's only a model, but the XC pilots in the summer, they will look at RASP, they will plan a flight, and it's amazingly accurate how it works. But any model is just a model, and you're quite correct. It may be nothing like the day. And
I just find it hard to recognize the different structures that are in the sky and relate them to what they're meant to be, relating clouds to fronts and so forth.
Okay, that's, sometimes it's not blindingly obvious, but if you look at the fronts and you kind of look at the way to do it is take a look at what they're supposed to be, take a look at the forecast, take a look at the synoptic and see where the fronts are moving through. And then you think, okay, there's supposed to be a front coming through about this time. What can I see? Oh, okay. And depending where you are, sometimes you can see these really distinct lines of cloud which delineate fronts. What you will commonly get, especially with warm fronts coming through, you'll see the high cirrus coming through like the day before. You see that, okay, there's probably a warm front coming through. There's little things like that. Cold fronts, the rain, the squall front, the wind gusts in front of it. You know, there are phenomena like that you will, once you start to look for them, you'll see them. And I say, just use the synoptics. Don't just rely on the local forecast. Look at the synoptics, get the bigger picture, and look at the characteristics, look at the diagrams. You will start to see it happening. You'll start to recognize fronts, when it's good, when it's bad, that sort of thing. Do that. So I've just noticed that you very keenly have an air chart positioned behind you, Andrew. Very good. That's actually not a bad idea. One of the things you will get asked about symbols on the air chart. You'll get, what does this mean? What does that mean? The only way you get to know what they are is you look at an air chart, you look at the symbols, and you find them on the air chart. All joking aside, what Andrew's done is actually, if you can stick an air chart up somewhere, just glance at it each day, have a look at it, look at the symbols, spot things. It's a very good idea. That's not such a silly thing to do.
Andrew, if it's behind you, it's only us who are going to benefit from it.
Yeah, I imagine he can turn his chair and look at it there, Abby. I don't think he's that struggling. You know, I think he has the ability to rotate.
I just moved the wall.
Yeah. Yeah, cool. All right, good. Anything else? I mean, I'm happy to answer questions on anything you've got, but I'm not trying to go through the whole syllabus. I'm just trying to, you know, A, encourage you to do it. B, make it less frightening. You know, C, just give you some tips on studying to get through it. And just, you know, as I say, do your study, go through the book. You'll be fine. You will, you know, anyone that prepares for it passes it, basically. Generally, the people I found haven't passed it, I check with them afterwards, like, oh, well, yeah, I didn't bother studying this, or I didn't bother covering that. I was like, well, okay, not really surprised you didn't pass it. It's like no mystery.
So is the exam held every month, once a month?
No. It's basically, we organize it as people need it, or like Inga, you can, often if you go back to whichever school you came through, they'll help. You'll say, look, I want to do my pilot exam. They'll say, okay, fine, I'll order it in for you. Come and sit. Here's a wet day, not doing anything else. Sit in the back room there and answer it. They're very good at that. You know, most of the schools are very keen to help you get your pilot rating and you know, progress. If you really can't do it through the school, if you get hold of myself, get hold of Greg, we'll arrange something. You know, one way or another, we'll sort out making it you enabled to do pilot exam. So it's whenever.
That's good to know. Yeah. Thank you.
Yeah. So don't panic. Don't panic. I think the other thing about being pilot rated is there are some countries as well, I think particularly Switzerland, you need to be IPI, which is your International Pilot License 5, and you only get that when you're pilot rated. So that's just a separate point. Doesn't affect everybody. Not everyone wants to fly abroad, but you'll find some areas where you need to be pilot rated to get the relevant IPPI rating, so you can go and fly there.
Does it help with insurance? If you're going abroad, for instance? No.
The insurance companies have no clue.
Okay.
You're partaking in a dangerous activity. You will be charged for it. They don't care if you're pilot rated or not. It's like, no, sorry, hazardous activity. Give me the money. Right, so, which is fair enough. So, no, it's just you know, it pushes you a bit as a pilot. It increases your knowledge and understanding. It allows you to fly XC if you want to, unsupervised. And I say, treat it as a learning tool. Treat it as something that will improve your flying. Don't just treat it as some school exercise to get through something, to get a piece of paper. And then you benefit from it. You know, don't just do it and think, oh, I can forget about it now. It's part of your ongoing pilot development to make you better pilots, quite simply. So it's worth doing. Okay.
Good.
Cool. Well, thank you for tuning in. And I say, if you have other questions, you can get on. You can always send me a message or something, and I'll do my best to sort it out for you. One new message. New message. What was the message to everyone? Okay. No problem.
All right. Thank you very
all
much.
right, guys.
Brilliant.
Thank
Thank you very much indeed.
Yeah, I'll get this converted and I will get it shared, and then you can go through it at your leisure and see if you can extract something from it. But I will dump notes on. I'll try and do it tonight. I've got some other work to do first. Certainly by tomorrow, I'll get the PowerPoints on the Telegram group so you can download them from there.
Thank you.
All right, guys. Thank you for attending.
Night,
Thanks very
everyone.
much, John.
Thank you.
John. Thank you.
Okay,
Bye-bye.
bye. And then